Good morning. Okay, I'm gonna take you MCQ 1, the multiple choice questions. Okay, so question 1.1, I'm gonna skip it because that that topic has been ruled out, I suppose. So those processes, I do not think you need to know them as much. 1.2, the question goes, which one of the following homologous series is saturated hydrocarbons? That shouldn't be difficult. You know that is definitely an alkane. So if you know the theory part of this, then you're safe because a hydrocarbon, you know it has to have hydrogens and carbons only. So esters are definitely wrong. Then they need to be single bonded to one another. So that is definitely option B. When we move on to 1.3, which one of the following pairs of compounds are members of the same homologous series? You need to know your background theory there. Homologous series, they have the same general formula. So in this case, we expect the ratio of carbons to hydrogens to be the same for our whatever members they're asking that have the same homologous series. So when you observe A, the ratio of C to H to hydrogens, the first molecule, it is what? 1:2. So that is an alkene. Then when you look at the other one, even if you don't know what that one is, the fact that the ratio is no longer 1:2, 4:10 is not the same as 1:2, unless the 10 was an 8. So definitely that one is wrong. So look at how I'm going to be working this. Even the other multiple choice, I just look for the most wrong answer, then until I'm left with the right one. And in case I find the right one, simply by observation. If I find the right one, then it's fine. If I can't find the right one, I just look for the most wrong answers. Okay, so B, CH4O and CH4O2, C2H4O2. Okay, so in the first one, the ratio is 1:4, but when I observe the next one, 2:4 is 1:2. Different ratios. Even the oxygens, maybe they could have simplified, but the fact that the CH4 and the C2H4 are different, it means those are different formulas. I don't know what A is, could be an alcohol, could be an aldehyde, could be a ketone, but then I don't care about that. Why? Because I'm simply looking for two molecules that have the same general formula, that have the same ratio of carbons and hydrogens. Then I move to C. When I go to C, the ratio of C to H is 2:4, which is 1:2. Great. When I look at C3H6, the ratio is still 1:2. Then the oxygens are the same, 2:2. So it means the correct answer there is definitely C. And then I don't need to look for D at D. The moment you find the right answer, you move on. 1.4. In the following diagram below, butane reacts to produce compound B in reaction 1. Compound B undergoes addition polymerization to produce polyethene. Remember what I said in yesterday's lesson? Polyethene, the monomer for polyethene is an ethene. So it means that B has to be ethene, and for it to be ethene, that is basically an alkene. So it has to be an alkene. Then when you observe the first molecule is butane, so from butane to an alkene, that is definitely cracking. But let's assume you didn't know that it was cracking. Then you need to look at the options and rule out the most wrong answers. First of all, that is butane. It's a saturated. It cannot undergo hydration, because hydration, you're adding something, you're adding water. And remember, we cannot add to a saturated, we can only add to an unsaturated molecule. So B is wrong. C, dehydration. Now, we can't dehydrate a butane because it's not an alcohol. Unless they had said it's an alcohol, then we'll think, yeah, maybe it could be the answer. But the fact that that's not an alcohol, we can't dehydrate it. Then D, dehydrohalogenation. Butane didn't have any halogen there. So how can we get a halogen from it with the hydrohalogen if we do not have to begin with? So C, D is wrong. So that leaves the answer as A. So whether you knew that A was the correct answer or you didn't know, you're supposed to just remove the most wrong answers and remain with the most right answer. Okay, then 1.5. The yield in a certain reversible reaction at equilibrium at temperature T and pressure P is 40%, okay? A catalyst is added to the reaction mixture at the start of the reaction, and the reaction reaches equilibrium at the same temperature and pressure. What effect will the addition of a catalyst have on the yield and the rate of reaction? Okay, so first of all, this is a catalyst. We know what a catalyst does to the rate of reaction, right? It increases it. It has a positive effect on the reaction rate. Remember, we said it lowers the activation energy and all that, speeding up the reaction. So why am I saying this? It is in order to reduce our number of options. So now we know that B and D are wrong. So the only options left are A and C. Then you observe what is different between A and C. In A, they said it remains 40%. In C, they said it is higher than 40%. Now, a catalyst, remember, according to Chatelier, we said there must be a disturbance. A catalyst doesn't cause any disturbance because either way, it speeds up both reactions, forward and reverse. And according to Le Chatelier, the factors that we looked at are pressure, which has an effect if they are only they are gases, concentration, which has an effect on gases and aqueous solutions. We looked at temperature, whereby we said if the reaction is endothermic, it will be favored. If it's exothermic, it will be, when you decrease temperature, you'll favor the exothermic. Now, in this case, temperature was kept constant, pressure was kept constant. So the only change that they told us here was addition of a catalyst, and the catalyst does not change, it does not shift the equilibrium position. So the correct answer there will definitely be A. All right, then 1.6. Now 1.6, they say the graphs given below show how the vapor pressure of secondary alcohol and the tertiary alcohol of equal molecular mass change with temperature. Okay, equal molecular mass, it means they have the same molecular formula, right? Because so that the mass is the same. Vapor pressure, okay, funny unit there, it's actually mercury, whatever, not necessary, as long as we know that the atmospheric pressure is that, it's fine. Then by definition, we say boiling point. Okay, they're asking which one of the following is the boiling point of the secondary alcohol. By definition, we know that a secondary alcohol, boiling point is the temperature at which the vapor pressure of the molecule is equivalent to atmospheric pressure. So atmospheric pressure, they told us that is 760. So it means that we are looking for temperatures where the vapor pressure of our molecules are at that point are equivalent to 760. So we look at the first one, it is 80, the other is 100 from the graph. So it means that the only options that we have there is 80 and 100. So meaning that C and D are already out. So now our debate is it A or is it B? Now, is it A or is it B? Now that depends on our knowledge of intermolecular forces, because this is about, So intermolecular force wise, we know that secondary alcohols tend to be longer. They have a longer chain length compared to tertiary alcohols. Tertiary alcohols are like more compact, they have less surface area compared to secondary alcohols. So now a secondary alcohol, we know that it will have to have stronger London forces, and also to have if stronger London forces, then definitely it must have what a higher boiling point. Okay, so it means the answer there is gonna be B. Yeah, so the answer there has to be B. Then we go to 1.7. The following acid-base reactions occur spontaneously at the same temperature. Okay, all the solutions have the same concentration. Okay, the dissociation constants Kb values are as follows. Kb, B bases. Okay, so more basic. We shall see which one is more basic there. As follows. K1 is for HPO4. K2 is for carbonate ion. Then K3 is for that HSO4 minus. Okay. Which one of the following correctly shows the order of increasing Kb values? Right, now all I need to do is find the base. The one that is the base here, let's see if the one that is acidic will have to have the lowest Kb, right? So let us see, from A, we observe the 2, HPO4 2 minus, then in the end we got PO4 3 minus. What does that tell us? It lost a hydrogen, it donated a hydrogen. So according to Bronsted, he says whatever donates a proton, that is gonna be what? An acid, right? So HPO4 is an acid. Okay, so what does that tell me? If it is an acid, it means that HPO4 cannot have the highest Kb value. So any option there from our options that shows K1 to have the highest, because they said increasing. So if any option shows the K1 to be the highest, it means it is wrong. So B is out, wrong. Now we look at carbonate. The carbonate, obviously there you can see it was basic, so we'll just keep it there for now. So we think K2 has to be in the end. Okay, we are just assuming it has to be in the end, so it means D is now, can be possibly the right one, but then K2 can also be in the middle. It just depends on the HSO4 minus. So now let us look at the HSO4 minus. So when you look at reaction number 2, HSO4, what happened to it? It went from HSO4 minus to SO4 2 minus. So it actually donated a hydrogen. So if it donated a hydrogen, it means it's also acidic. So now if it is acidic, what does that tell us? It means that its Kp value needs to be less as well. It can't be high because it's not basic, it's acidic. So now knowing that, so it means that the only basic here is the CO3 2 minus. So it means K2 has to be the correct answer, the highest. So the option there will be D. It would have been confusing if they had changed the 3 and the 1 and interchanged them. If we had two options that had K2, then it will be slightly confusing. But here the method that I'm giving you is you just try to find the most wrong answer and you proceed. Don't think about much. If you have seen that, okay, this has to be, that is it. So D is the correct answer. 1.8, which one of the salts below produce an acidic solution when dissolved in water? All right, acidic. So for it to be acidic, remember what I said. For a salt to be acidic, then it means that there must be an imbalance in its ions, basically, those that formed it, right? The acids that, or the acid and the base that reacted together. So if we are getting an acidic, we just need to, okay, look how we're gonna do it, no? So A, sodium and carbonate. All right, so sodium, remember sodium is what? It's a strong base. It came from NHO4, right? NaOH, that is sodium hydroxide, the strong base that we know. And remember, the strong base will yield a weak acid. Okay, so that one is out. Carbonate in this case, carbonate was basic, right? So we leave it for now, but the fact that this one has produced a weak acid, okay, so NaOH was a strong base. It created a conjugate acid which is weak, and the question is saying we need an acidic solution. So it means already A has to be, it's not gonna be acidic at all because that is a weak acid. Okay, then B, sodium chloride. Na, we know it came from NaOH, which is a strong base. Cl came from HCl, which is a strong acid. So both of these strong base and strong acid, they yield what? A weak conjugate and a weak conjugate base and a weak conjugate acid, right? So in this case, that one is practically neutral, right? Close to neutral, because there is a balance there. Both of them are weak acid and weak base that form. Then when you observe C, we have ammonium and chloride. So chloride, we know that it came from a strong acid, from HCl. So if it came from a strong acid, it means it's going to form a weak base. Ammonium came from ammonia. Now remember, ammonia is one of the weak bases which we spoke of yesterday. So a weak base is going to give what? A stronger acid, a stronger conjugate acid. So it means that NH4 is it's kind of a strong acid. So in this case, C is the most right answer. There's no need to even proceed to D. But if you were to do that, you know that K came from KOH, which is a strong base, so yielding a weak acid. NO3 came from HNO3, which is nitric acid, which is a strong acid, so it's gonna be what? That it's gonna be a weak base, right? So the correct answer there is C. Okay, then 1.9. Which one of the following is the strongest reducing agent? Reducing agent reduces the other. I think there the answer is just that I do not have the access to that, but I think you can simply get your answer from that table, the 4p table. Just look for the one that can undergo that is the strongest reducing. Remember, they show you the arrow there in terms of increasing reducing ability. You just find the right one there. Then 1.10, an iron nail is electroplated with silver. The half reaction takes place at the iron nail is given by. We are electroplating this iron nail with silver. So it means that, okay, simply put, we need silver there, right? We need to form silver that is gonna, attach to that iron nail, an iron nail of ours. So meaning that the iron nail needs to change to a silver color. We're electroplating, all right? Basically putting a layer of silver around it. So that one is easy. Definitely the answer needs to be D. And as a matter of fact, whatever we are always, when we are electroplating something, a reduction reaction needs to take place at that electrode where electroplating is being done, okay? Because we need to form that metal which we want to make a layer of on that particular metal of ours that we'll be trying to electroplate. So in this case, the answer is definitely D. It's not A because we are not electroplating it with iron. It's not B because why would we need oxidation? We don't want ions. There we need iron. Okay, even iron we don't need it. So in case iron we don't need it, we want silver. Then C, silver to silver ions. No, we don't want silver ions. We want silver to be the layer there. So the answer is definitely D.